Welcome back. Today we're going to be talking about how to factor equations, and there are two main strategies that I'm going to be using throughout. One is the diamond method that I learned years and years ago. That is honestly my holy grail. And then also to make sure you set everything equal to 0 so that it's easier to work with. So I have three main variations that we're going to work with. Each of them have two problems. One I'm going to work through step by step, and then another one I'm going to kind of prompt you to pause and work on your own, and then I'll go through how I solved them. But yeah. Alrighty. The first one we're going to do is when you have you have a variable set to another variable. So, sorry, let me move my note. Okay. 1 is going to be x squared equal to 8x. Okay, so I also recently made a video on zero factor property. So this one, just because it is more simplified, does call back on that. But the first thing you want to do for here is you want to set everything equal to 0, like I mentioned. So we're just going to move this 8x over just because it's kind of easier than working with a negative x squared. So x squared minus 8x equals 0. And again, you can kind of, the way that there's like a invisible 1 coefficient in front of this x squared, you can kind of view it as there being like a invisible plus 0 after this 8x, which is why we can then set it equal to 0 when we move it over to the left side. Okay, and then after that, it's honestly just zero factor property. So what you're going to do is you're going to take each of, you can factor out an x from each of these. So it's going to be, you're going to pull an x from this one, so you'll be left with 1, and then you're going to pull an x from this minus 8x, so you'll just be left with minus 8. And then both of those, and then just set that equal to 0. This is the same exact function as what was written above. It's just rearranged a little bit so you can work with it easier. And then this is where you get that zero factor property, where you just have x equal to 0, which is done, it's simplified, and then x minus 8 equal to 0. And then this leads to x equals 8, because you'll just add 8 to both sides. And those are your answers, and then you'll go through and check your work. And remember that when you're checking, you're going back and you're plugging it into the original equation. So this one, so if we're going to check, does x equal 0? Sorry, this blue is kind of aggressive. It'll be 0 squared equals 8 times 0, and 8 times 0 is 0. So 0 squared is also 0, so 0 equals 0. Check. So this one is all good. And then this x minus 8 equals 0. Just plug in the 0 for the x. Or no, sorry. Plug in 8 for the x. So 8 squared equals 8 times 8, which is fundamentally the same thing. 8 squared is 64, equals 8 times 8, which is also 64. So this x equals 8 is also verified. So your answer is x equals 0, comma x equals 8. Okay, if you understood how to do that one, then you're good. This is just another example. Again, this is kind of like the challenge to work it out yourself and then kind of see how I did it. So again, that cliche of pause and then kind of try to work it out, see how far you can get, what you understand, and then try to also do the check, make sure that the numbers that you get work out, and then come back and I'll work through it. Alrighty, let me just rewrite and then we'll work through. Okay, so for this one, 2x squared equals 4x. So again, we're just going to try to set this all equal to 0. So we're just going to rewrite it, 2x squared minus 4x equals 0. I think I'm just going to work in this purple. I like this color better. Okay, and now it's kind of just factoring it out. the diamond method that I mentioned is more so for the next two sections where you have 3 terms or 3 or more terms. Because for this one, you kind of see that you can take out a 2x from each of these. So that's what I would factor out as a 2x, which from this first term, because when I say term, like it's separated by any of these like mathematical symbols right here. So like 2x squared is a term, and then 4x, or this negative is going to travel with the 4x, but that's its own term. So from each of those, you can take out a 2x, and then you're left with x minus 2. And if you need more in depth, I'm sure there's like other videos. I'm kind of just operating from like an algebra understanding, moving into calc. Okay. And then set this equal to 0. And then again, we just return to the 0 property, or 0 factor property, which I did like another breakdown on. So I'm not going to go like too in depth, but you just set each of these new terms, or these new like factor brackets into their own equations equal to 0. So you'd have 2x equals 0, and then x minus 2 equals 0. And these are both pretty straightforward. Divide by 2 on both sides, x equals, and then for the sake of this, we're just going to say x equals 0, and then add 2 to both sides, and then we'll say x equals 2. So these are now your 2 values that you then want to plug in and check. I'm kind of just having fun with the colors, so we'll check in green. And again, make sure that you set it back into this original equation that you got. So if we're doing x equals 0, we'll do 2 times 0 squared equals 4 times 0. And then we're just going to have 2 times 0 squared is 0, so 0. And then anything times 0 is 0, 4 times 0 is 0 again. So that checks. So x equals 0 is good. And then for x equals 2, plug in 2 for wherever you see an x. So 2 times 2 squared equals 4 times 2. So then this 2 squared is just 2 times 2, so it's 4 in parentheses. And then 4 times 2 is 8. And then again, these are just fundamentally the same things. 2 times 4 is 8 again, so 8 equals 8. That checks out. So x equals 2 is also an answer. So your final answer, x equals 0, comma x equals 2. Perfect. And now we're going to move on to a different like variation, and this is when I'm going to use the word FOIL, which is also just something that I learned so long ago. But it basically just means first, outer, inner, last. And this is going to make sense with our next example, which is when you have them kind of already factored out in a sense into these two sections. So this example we're going to do, however, this time it's going to be equal to a number that is not 0. And for this one, we're going to say it's equal to 20. So if we're going to FOIL, it just means you're going to take these, we're going to FOIL so that we make a longer equation, so that we can find the numbers that x could be equal when we set it to 0. It's going to make more sense like when I factor it out, but that's the goal. Because we want to set this equal to 0. We don't want it equal to 20. It's just a little cleaner and kind of help simplify it out. But yeah, okay, so first is these first numbers, or these first, they're variables, we'll just call them that for now. So it's going to be x times x, which gives us x squared. And then we're going to do, so we've done our first, and now we're going to do outer. So it's going to be these terms that are on like the outer edge of the parentheses. So it's this x times the negative 6. So you're going to get negative 6x. And then we've done outer. Now we're going to do inner. So it's the ones on these inner parentheses right here. So it's this, I'm trying to write it so they're in order. But it's this 2 and this x. And when you're doing all of this, you're multiplying them. So We've multiplied x times x to get x squared. We multiplied x times negative 6 to get negative 6x. And now we're going to multiply this 2 and this x to get 2x. And then now we're going to do last. So it's just the last placeholders that we have in these parentheses. So it's going to be this 2 and this negative 6. So it's going to be negative 12. So this looks messy, but that's just because I was trying to like trace as we were working through. But when we do these first, right, so the first ones that we did were the 2 x's. So when we're rewriting it, we have x squared. Then we did our outers, so our x and our negative 6, negative minus 6x. And then we did our inner, these two, the 2 and the x, plus 2x. And the last, the 2 and the negative 6, negative 12. And this is still equal to 20 right now because we haven't done anything on that side. But now that's what we're going to do. We're just going to transfer this over. So all of this is just going to be written the same. X squared minus 6x plus 2x minus 12. And then we're going to subtract this 20 to move it over to the left side. And then we're going to set it equal to 0. Because again, we have that plus 0 that's kind of hanging out because we didn't really care about it before. So yeah, and now you just have these what are called like terms, where they have the same like variables attached, or they have the same like setup, where like how you have these, the negative 6x and the 2x, they both only have a singular x with a coefficient in front, whereas this x squared, that's different. It's a different notation on the x. And then the negative 12 and negative 20, those are both constants, which mean that they don't have a variable attached to them as they are. So because these are like terms, you can just combine them so that it's simpler and it's easier to understand all of them that you have. They're kind of just grouped together. So you would rewrite this as x squared minus 4x minus, wait, where's my thing? Minus 32, right? Okay, minus 32 equals 0. Okay, so this is our new equation that we're going to be working off of, and this is what we're now going to use the diamond method for. What color do I want to do? Red. Okay, so the diamond method, I'm just going to write it over here. It's honestly, it's just like this big X. I just call it the diamond method because I think that's how I was taught it. But what you're going to do is when you have these, like these 3 terms, I just refer to them as A, B, and C, right? And in the diamond method, you're gonna do A times C. You're gonna multiply those together, and then you're just gonna have B in this bottom one, and it's gonna all fill in. But in this top one, it's going to be a number, right? So when we multiply A times C for the numbers that we have, we get negative 32 in our top box, and then we just put in the B value, which we have is negative 4. Right? Okay, so then what you're going to be looking for is 2 numbers to put in these side triangles, and these numbers need to multiply together to be the value in this top one right here. So you're looking for numbers that multiply together to equal negative 32, and then those same numbers need to add together to equal this B value, or equal negative 4. So I've already worked through all of these, so I just know the numbers, but for this one, it can be kind of trial and error. So when you're first learning this, it's beneficial to kind of just have, just write down this number that you're trying to find up here, 32 right off to the side, and try to find numbers that multiply together to equal that. 1 and 32, 2 and 16, is that true? 3 doesn't go into this, but 4 does. 4 times 8 goes into 32. And coincidentally, these are the numbers that are going to be the ones that work best for us, because we're going to have 4 and 8 go into 32, but we have a negative one. We have a negative 32. So one of these numbers needs to be negative, and then we have a negative 4, so the larger number is going to be negative since this final number stays negative, if that makes sense. So we're going to have a negative 8. Yeah, okay. So then we're going to transfer these numbers over here, the negative 8 and the 4, and we're going to rewrite this equation that we have right here in electric blue so that we can factor those out. Let's write it in red. Okay, so we're going to have x squared, because we didn't change anything with that, plus 4x minus 8x minus 32, because we also didn't change anything with that, equal to 0. Okay, and then I was also taught like to kind of just separate these down with like a little dashed line and kind of solve them as though they're two separate equations and just factor them out that way so that it moves a little quicker and you can kind of see what's going on. So you're going to be able to factor an x from this left side, and then it's going to be x plus 4. And then from this right side, you can factor out a negative 8. So you're going to factor out negative 8, and then you have x plus 4. And you do this because what you want is to have the same parentheses, like the same values in the parentheses on both sides. And then that is one of your factors, x plus 4. And then your other one is you're going to combine the values that were on the outside. You're going to have x minus 8 is your other term, and then you set those equal to 0. And then again, moving forward, this is just the zero factor property. So you set both of those terms equal to 0 and solve. So x plus 4 equals 0. So subtract 4 from both sides. So x equals negative 4. And then x minus 8 equals 0. Add 8 to both sides. So x equals 8. And then you would go through and you would check these terms, which I'm going to do on the next slide because this one's kind of busy. Okay, so we return to our original equation. I'm just write it down really quickly. And the variables that we're testing are x equals negative 4 and x equals 8. So again, we're just going to plug in for the x values, the ones that we're testing. So if we're testing x equals negative 4 plus 2 in parentheses multiplied by negative 4 minus 6, and we want to see if this equals 20. So negative 4 plus 2 is negative 2 times negative 4 minus 6 is negative 10, and two negatives multiplied together is a positive, so we get 20 equals 20. So that checks out. So we know that x equals negative 4 is a possible solution. And then we have x equals 8 as one we want to test. So we're going to do 8 plus 2 in parentheses multiplied by 8 minus 6 to see if this equals 20. 8 plus 2 is 10. And we're going to multiply that by 8 minus 6, 2. So this one is also pretty straightforward. 10 times 2 is equal to 20. So 20 equals 20 checks out. So 8 is also a possible option. So your final answer, x equals negative 4, comma, x equals 8. And what can be kind of tricky is when you first look at this, you may want to say that the answers are negative 2 and 6 because those are, if you were doing zero property, that's all you'd have to do. But this isn't equal to 0. So there's more work that needs to be done to get to that final answer. So yeah, okay, the next one is also going to be your turn. So if you feel good about this, if the review helped, you can definitely skip that part. If not, again, I'm just going to write down a problem and then give you like a second or two like to pause the video, and then you work through, see how far you can get, see and check the numbers that you get, and then I'll show how I did it. Okay. Write these down. Okay, so this is the problem, and then feel free to pause. Alright, so again, we're gonna FOIL. these two to get our new one, and then so we can also move the 12 to the left side. So we're going to do our first ones, x and x, so we have x squared. We're going to do our outer ones, x and 3, to get plus 3x. We're going to do our inner ones, negative 8 and x, to get minus 8x. And then we're going to do our last ones, negative 8 and 3, to get negative 24. And this is equal to 12 because we haven't done anything to that side yet. But we are going to move it over to the left by subtracting. So we're going to just shift down all the numbers that we just got. And then subtract 12 and set that equal to 0. Alrighty, and from here we're going to combine our like terms. X squared minus 5x minus 36 equals 0. And then this is when we'll do the diamond, which is on, it's love and hate because sometimes it's so quick and sometimes it's really not. But okay, we have our A, B, and C. So A times C, we have that invisible 1. So 1 times negative 36 is negative 36. And then we're just going to transfer this B to the bottom, negative 5. And we're just going to spend time thinking of what two numbers multiply to negative 36. And then when you add them together, you get negative 5. And those numbers happen to be 4 and negative 9. Again, sometimes it's trial and error, sometimes it's more apparent, but that's more so algebra topic. But okay, and then we're just going to do the same thing that we did in the previous one, where basically what we're doing is we're breaking down this negative 5x into the 4 and the negative 9 when we rewrite it. So it's x squared plus 4x minus 9x, because we just want to keep all of the like terms next to each other. And then we're going to subtract 36. And again, I was just taught to do like a little dotted line and treat them as two separate equations. There's other ways to do it, I'm sure. That's just kind of what seems easiest in my mind. So when we have these little mini equations, we can see that we can take out an x from both of these, and we're left with x plus 4. And then on the right side, we can take out a negative 9, and then we're left with x plus 4, which is fortunately also the one that we got in the previous parentheses. And you want these to be the same. If they're not the same, it's a little more complex. You might have done something wrong. It might just be the problem. It's just better when these are the same, which is also just kind of a way to mini check while you're doing the work. So then we just rewrite x plus 4 times x minus 9, and then this is equal to 0 because this equation that we've just factored out is equal to 0. And then again, it's just the zero factor property, which is a video that I already did more in depth. So if you kind of want to understand that better, I would check that out. But these ones are pretty straightforward. It's you just set what's in the parentheses equal to 0, because the whole equation's already set to equal to 0, which is key. So x plus 4 equals 0. Subtract 4 from both sides, and you're left with x equals negative 4. And then x minus 9 equals 0. Add 9 to both sides, and you're left with x equals 9. And then this is when these are our possible solutions that we want to check. What color do I want to do? Let's start blue, I guess. And again, we're just going to plug this back into the original equation. Where it's equal to 12 instead. So if we're testing x equals negative 4, we have negative 4 minus 8 in the first parentheses multiplied by negative 4 plus 3. And we're trying to see if this is equal to 12. So negative 4 minus 8 is negative 12. And then we're multiplying that by negative 4 plus 3, which is negative 1. So negative 12 times negative 1 is equal to 12. So this checks out, and negative 4 is a possible solution. Then if we're going to test x equals 9, 9 minus 8, in that first parentheses, and then 9 plus 3. And we're going to see if when you multiply those together, you get 12. 9 minus 8 is 1. And then we're going to multiply that. 9 plus 3 is 12. 1 times 12 equals 12. So this also checks out, and x equals 9 is another possible solution. So your answer is x equals -4, comma, x equals 9. Alrighty, and then we're almost done. We're going to move on to the last variation. Okay, this slide is also going to be our last two problems, and this one is more so when you have it already written out and set equal to 0. So they're all of the ones that the order that we've been doing it in, they kind of like build on each other. Since this one's already expanded, you would just need to do the diamond method. You don't need to switch anything over to the left side. So our first example for this one is x squared plus 14x plus 45 equals 0. So this one, again, like I said, since it's already set equal to 0, you can go straight to the diamond method, which is when you have those a, b, and c, and you set up a times c in the top one and b at the bottom one, and you're trying to find the numbers that make those true. So you have 1 times 45, so we have 45 in this top one, and then we have 14, which we just transfer over, and then again, I've already worked through these like problems before when I was setting up which ones I wanted to do or like how I wanted to explain it. So I know the answer, or I know which numbers go into these side triangles, but this is a step where you would think of what numbers multiply together to equal 45. It's usually not going to be 1 unless this b number is I don't know. It's usually if it's 1, it's going to be a little more straightforward. So I try to think of some of the like I'm more like convoluted ones, I guess. 2 doesn't go into this neatly. Also, they're usually like for exams I've had and quizzes and homework, it's usually going to be a pretty straightforward number. It's not going to be like 2.5 times this number. But yeah, I'm just rambling now. But for this one, it's going to be 5 and 9. Because 9 times 5 is 45, and then 9 plus 5 is 14. So that works out. And then again, we're just gonna write this through. We're just gonna transfer it because all we're doing by doing the diamond method is just breaking down this 14 so that we can factor it out a little bit easier and get those possible solutions for x. So we're gonna have x squared plus 9x plus 5x plus 45 equals 0. And then again, just that dotted line to kind of separate them out, and then just factor those. So you can take out an x from both of these. You're going to have x plus 9, and then you're going to have 5 that you can factor out from the right side, and you're left with x plus 9 as well. And then again, which we did this in the previous problems, how to rewrite it this way, but x plus 9 times x plus 5, and you could switch the order that these are in. It doesn't matter. It's they're gonna work out the same way. Okay, let me set these equal to 0, and then again, just 0 property. And I try to make all these pretty like straightforward once you get to this step, because it's more important to kind of understand how you get here for problems in the future once we get into like the calculus part. But x plus 9 equals 0, subtract 9 from both sides, so x equals -9, x plus 5 equals 0, subtract 5 from both sides, x equals -5. So these are possible solutions, and then we just want to plug them into our original equation to check to see if they work. Okay, so our original equation is x squared plus 14x plus 45 equals 0, and we're going to test -9 first. So we're going to do -9 squared plus 14 times 9 plus 45 equals 0. So it's also important that you put this -9 is in parentheses. This is also going to come back in like future problems, where it's just important to remember that this, like the negative, if the negative is starting with a 9, it's going to travel with it into the parentheses. Otherwise, you can get the wrong answer and then it switches things up and it makes it not work. But this is going to go, it's glued to the 9 for this problem. So also when you get to these problems, it's kind of, this is when it's handy to have a calculator and just like use your resources, but they're not super big numbers, so they're still workable. We're gonna have -9 times itself is going to be positive 81 plus 14 times 9, which is going to be 126. Well, it's going to be, sorry, this is a -9. 81 minus 126 plus 45. And we're going to try to see if this equals 0. So when you calculate it out, this 81 minus 126 is 45, and then is a -45 plus this 45 right here, which equals 0. So this -9 does check out, and it is a possible solution. And now we're just going to do the same thing with our -5. So I'm just going to rewrite the original equation, and then we'll plug in. Again, that -5, that negative is glued to it, so it's going to travel with it into the parentheses. Plus this 14 times -5 plus 45 equals 0. Alrighty, so then this -5 times -5 is a positive 25 minus this 14 times -5 is going to be -70, and then plus this 45 that we just carry down equals 0. And then this 25 minus 70 is -45 plus 45. Again, we're just dragging this one down. And this does equal 0. So this -5 is also a possible solution. So your final answer is x equals -9, comma x equals -5. Alrighty, and then if you understand from here, then you're all good to go. I'm just going to do the 3A or like a your turn to check to see if you understand. Okay, this will be the last problem for this video. And this one I did add a coefficient for the first x squared, or not the first, but to the x squared. So you have 3x squared minus 7x minus 20 equals 0. And this one I wanted to make it a little bit more challenging, so I added the coefficient and then I made it 20, not 21, so it's not as easy to factor out. But yeah, but we're just going to start, we're going to tackle it, all shakes out in the end. So we're going to start with the diamond method. Again, I just think it's just visually helpful, and make sure that you keep track of all your numbers. So again, we have the A, the B, and the C. So the diamond is that A times C at the top, and then the B, so you're trying to find numbers that multiply to this number, and then that add to this bottom number. So 3 times -20 is -60. And then we're just going to move this -7 over here. And this one, it would be so fun if it was just 6 and 10 or 3 and 20, but it's not. The numbers that actually work out for this one are going to be -12 and 5, because 12 times 5 is 60. And we know that's negative, so one of these numbers is negative. And we know that the bottom number stays negative, so the larger value is going to carry that negative sign. The smaller one will be positive. So that's kind of how it works out. And then we're just going to move with the same steps that we've done before, where we are using this -12 and 5 to break down this -7. So it's going to be 3x squared minus 12x plus 5x minus 20 equals 0. Alrighty. And then same with that little dotted line to help keep things organized. So from this left side, you can take out a 3x, because 3 goes into 12, and then we know that both of these have an x in them, so 3x. And then we're left with x minus 4, just that 12 divided by 3. And then on this right side, we can take out a 5, and we'll get left with 5 times x minus 4, because 5 times -4 is 20. And then we'll just rewrite this so that this 3x and 5 are in the same parentheses. We'll have x minus 4 and 3x plus 5. And we're going to set this equal to 0. Since this is all the same stuff, it's just reorganized from the original equation. Okay. And then again, from here, it's just a zero factor property. X minus 4 equals 0. Add 4 to both sides. So x equals 4 as possible solution. And then 3x plus 5 equals 0. Again, this one is, we're going to have a fraction, but it's all good. We're going to subtract 5 from both sides, where 3x equals negative 5. And then we're going to divide by this 3. So we're going to be left with x equals negative 5 divided by 3. So these are two possible solutions. The fraction one's going to take more space, so I'm just going to do that like over here, but right here for the check, where again we're going to plug it into this original equation that we had. 20 equals 0. And then we're going to plug in our 4 for the x. So 3 times 4 squared minus 7 times 4 minus 20. And we're trying to see if this equals 0. So 3 times, 4 squared is 16. Minus 7 times 4 is 28. Minus 20. 0. 3 times 16 is 48. So we're left with 48 minus 28 minus 20. And you can just plug all this into a calculator, or you can kind of see that 48 minus 28 is going to be 20. So we have 20 minus 20, which equals 0. So x equals 4 is a possible solution. And then we're just going to do the same thing that we just did to check this x equals negative 5 over 3. So we'll just rewrite our original equation. And we're going to plug in this negative 5, 3 where we see an x. So 3 times negative 5 over 3 squared minus 7 times negative 5 over 3 minus 20. And we're testing to see if this equals 0. Okay, so more palatable color. So this first part, this negative 5 over 3 squared, when you're multiplying fractions, you kind of just, like, you can just multiply across, so just think of it as having, like, negative 5 over 3 times negative 5 over 3, and then you just multiply across, so negative 5 times negative 5 is positive 25, 3 times 3 is 9, so you're left with 25 over 9. And then we're going to bring that down, and we'll multiply that by 3 in a couple minutes. And then we're just going to do the same thing and move all these other numbers. So we have our negative 7 times negative 5 over 3. We're going to have, I'm going to write it over here so it's more legible. And then it's also easy to just kind of like make this negative 7, write it over 1, just so it's in fraction format, and it's also a little bit easier to see the multiplication that you're doing, because this is essentially the same thing. This negative 7 over 1 is essentially the same thing as negative 7 by itself. So we have negative 7 times negative 5, which is going to be a positive 35, over this 1 times 3, which is 3. So because it's positive, now it's plus 35 over 3 minus 20. And this is all going to work out. So honestly, at this point, it's kind of just trust the process. Don't simplify just yet, because that's going to make it more messy when you're trying to do like fraction, or trying to do like decimals and all that stuff. Just keep it in fraction form for right now. And then what we want to do is we want to simplify, or we want to multiply this 3 times this fraction, so it's all 1. So what I want to do is get rid of this 9 right here. It's kind of encumbersome, it's kind of intimidating. So what we're going to do over here, again, in this little workspace, is this 3 over 1 times this 25 over 9. And this is kind of pulling from like past math like understanding, but over here you can simplify this 9 by like kind of like cross, I don't know like the right term for it, but you can divide by this 3 and divide this 3 by 3 and divide this 9 by 3 and get 1 and 3 so that it becomes 25 over 3. This part is kind of just like, if you know how to do that, do that. If not, don't worry about like overcomplicating it. Just multiply it through and stick with 75 over 9, which you can also then simplify by 3. So either way that you get to it, I just want to simplify it out so that we're left with 25 over 3 right here. Alrighty. And then we're gonna add all of this back down. And this part is kind of like, it's almost getting there. But when you're adding fractions, you just add, if you're adding fractions and they have the same denominator, you just add the numerators together, and 25 plus 35 is 60. So you have 60 over 3 minus 20, and again, we're still trying to make sure and check that this equals 0, but when we have 60 divided by 3, we know that that is just 20. So we have 20 minus 20, which equals 0. So that was a lot of work, a lot of side work, but at the end we find out that this is also a possible solution, just negative 5 over 3. So we're left with our final answer, x equals 4, comma x equals negative 5 over 3. Okay, I hope that was understandable and helped, and I challenge you to come up with your own equations, because it also helps like when you're like coming up with something like this, to kind of see how it works backwards and understanding which numbers work together and how it's all going to play out, and then kind of going through and checking. So yeah, also I recommend repetition and just like getting familiar with the content. That is what helps so much with feeling familiar and comfortable with the material, and then by the time it comes to exams or quizzes or homework, you kind of just go like, oh, I've seen this before, I've done this before, and you get into a flow. So yeah, that's all for today.